So, I appreciate everybody being here. I have been involved in manufacturing for 25 years, and in that time I've seen quite a lot of stuff come through CES, and I'm really glad that SME has put together this consortium as an opportunity for us to talk about how things are actually made. So we get a chance to take a look as consumers at a whole lot of cool tech, but how it's made and how it gets into your hands is really, really critically important. And we're going to talk a little bit about that. My background's not all that interesting. I've got a lot of gray hair from trying to make parts, but my expertise comes in helping companies go from tens of things to tens of millions of things. And so you can very much understand where I'm coming from in being very passionate about what this means to companies. All right, so let's jump into some of the meat of this stuff. When we talk about additive manufacturing, when we talk about manufacturing, the conversation right now is a lot about reshoring. It's a lot about shoring up supply chains. We all lived through COVID. We had a heck of a lot of time in trying to get parts and supplies. We need to find ways to be more single source in how we're getting things. If we can do that internally, that's even better. We need to help rethink what additive is. I talk to people all the time about 3D printing. It's what I do for a living. I know it quite well. Most everybody that I talk to at a show like this does not. How many of you realize that there's actually 3 technologies that are inside what we call 3D printing? There's filament printers, which most people are aware of, which are the ones that move around and they've got a big spool on there. But then there's also resin printing and there's also powder printing. We consider those 3 different technologies that are inside the word 3D printing. So we're going to rethink that a little bit. We're going to take a look at a couple of case studies, and I wanted to do 2 of them with you guys. One is a really small company called Cool Machines. One is a much smaller company called Eaton. I think actually they're over on that end. I don't think they're all that big of a deal. They probably won't last very long. And I want to talk about how they're using this to be faster getting products into customers' hands. And then if there's any time left, because I like to talk too much, we'll have some time from Nay. I'm here all week. Feel free to grab me over by the Formlabs. All right, so if you're not familiar with Formlabs, we are actually a company, we're one of only 2 companies that went through Kickstarter and have made it into full billion-dollar valuation companies. That is pretty cool. All right, we were started in 2012 with a passion of bringing manufacturing to everybody. And our goal was to make a box that was a factory in a single box. We make the 3D printers, we make the materials, we make the software, we do all the support, we do everything that you need in order to get there. But our core mission is we want to build the tools that make it possible for people to bring their ideas to life, whatever that might be. I'm going to brag just a second and we'll get into the meat, I promise. But we were founded in 2011 as a Kickstarter. Right now, we have over 130,000 printers out in the market. We have 300 engineers that are working on this. So we actually have the largest R&D in 3D printing in the world. And the one that I'm the most proud of is our customers are printing a part every single second. So we have over 400 million parts that have been printed, and they're out in people's hands right now. And that number is just continuing to escalate at a ridiculous rate. We make everything, so it's a fully integrated setup. So if you have any questions, someone reach out to us. We're happy to talk to you. We won't talk bad about anybody else, I promise. But let's talk about the core. Why are we here? We need to get parts into people's hands. Right now, first to market is almost as important as what the product is. And there's a lot of debate over if that's the right direction or not. And don't matter what camp you're in, it's important to get out there. I think the Neo humanoid is a good example, if anybody's paid attention to that one. It may not be the best product that's out in the market, but they're rushing to be first out there. You can look at other contenders like your Teslas from the EV side, your Netflix from a streaming side. They were first to get the product out into customers' hands, and they have a market advantage by being that way. In addition, if we're in the United States, we have a disadvantage against our Chinese competitors. Many of them can walk across the street and find somebody who can manufacture a part for them. We don't have that capability. We need to find a way to be faster. 18-week lead times, getting a mold made or a tool made and getting those parts back only to find out we made some sort of an error is unacceptable if we want to get a part out in time. Add into that the fact that there's IP protection, that we've got a lot of uncertainty from a political standpoint, it becomes challenging. When we think about traditional manufacturing, long lead times, high tooling costs. I do a presentation over at the Formlabs booth. We talk about a $12,000 tool that we had to do to injection mold a part, and it took us 18 weeks to get that tool to be ready to go. And then I talk to people constantly who are losing their intellectual properties overseas. It's not acceptable. When we think about traditional 3D printing, so the way you probably walked up to this booth right now and said, all right, there's a guy talking about 3D printing, maybe he's going to be interesting, and maybe he's just funny to look at. Most people consider it, we come up with an idea, we send it to a printer, we print the prototype, we validate the prototype is good, we send that out for tooling, we get the actual part finished. That is the traditional workflow. We have spent at Formlabs the last 3 years and millions of dollars to change that narrative. And we want to help shift from parts that look like the end product to are the end product. I'm going to give you an example, and if you come over to the booth a little bit later, I have a presentation. I've shown a couple of you. I recognize some faces here. I'm going to give away a bit of the game here. There's some parts that I have that are injection molded sitting on that table, and some that are 3D printed. And we actually went through and got a mold manufactured for these parts, and we sourced and produced parts, and then we also made them on a printer. And we found that we had about a 13,000 part cost convergence, where it was cheaper for us to manufacture those at a quantity of about 13,000 parts. At Formlabs, every year, our CEO sets an expectation. Last year, it was 10,000 parts of this specific part. We had to be able to make 10,000 of these parts at the same or lower cost than getting them injection molded. This year, 2026, it's 15,000 parts, so that number is going to creep up. And our goal is to get to 20,000. That's what we want to be able to tell people. If you're making less than 20,000 of a part, it's going to be less expensive to print it than it would be to mold it. We're under no delusions that we're going to completely replace injection molding. That is not the intent. If any of you come up here and think that's what I'm trying to do, that's fine. You can throw rocks at me, it's okay, but that's not what I'm trying to say. So let's take a look at some real world use cases. I want to talk about a small company called Cool Machine. Now, they're a US-based manufacturer, and they make insulation systems. So if anybody's ever had insulation blown into their attic or anything like that, I'm seeing some head nods. All right. How many of you think that those are produced by the hundreds of thousands, those insulation blowing machines? No. In fact, there's about a dozen companies that make these machines, and each one of them is quite happy if they make 10,000 of these machines in a year. That's a huge number for these guys. So for them to get tooling to do components just isn't very cost effective. The equipment has to be put under pressure, under temperature, and under Joe, who's the guy who's going to be using this, who probably doesn't really care a whole heck of a lot about that piece of equipment, and he's probably going to throw it in the back of the truck. So they had supply chain problems. If they wanted to make some sort of a modification, it was taking them months to do. Not only was it taking them months to do it, but they're a small company. Cool Machines is made up of 14 people. It is not what we consider a very large company. You're never going to see them on the Fortune 500 or the Fortune 10,000 list. So for them to be able to get large production runs to hit contract manufacturers' expectations just wasn't going to happen, or it wasn't financially plausible for them. In addition, they had issues where their contract manufacturer just gave up on them and wasn't going to be supporting them any longer for whatever reasons. I don't know all of them, but it led to a lot of issues where they weren't able to deliver product. The other issue they run into is there's other considerations from different municipalities. Some will allow certain types of blown insulation and some don't. And so the machinery has to have some slight alterations to it in order to meet all the different expectations and requirements. So they printed this part that you see behind me. They printed it in a tough 1000 resin, which is similar to an HDPE. It's a high density polyethylene for anybody who's not familiar with it. They actually did some significant testing on this and found that they were able to produce it similar to an aluminum CNC part. I like that shocked look. That makes me feel really good that I'm doing a good job here. They put it through 600 PSI of water pressure testing. They then froze it and dropped it 10 feet to make sure that it would survive Joe. I'm sorry, Joe, I'm not actually picking on you. Joe Fairley from Ascent Fabrication, great guy, great gentleman. In addition, because they're able to get these parts produced in a much faster time frame, they're not needing to do the tooling, they're able to get that cost per part significantly lower. So this is all thanks to the use of 3D printing some of the newer materials that are out there. All right, let's shift over to that other small company we were talking about, Eaton. So if you're not familiar with Eaton, they are a multinational conglomerate with close to 100,000 employees, hundreds of sites all over the world. But this story specifically is about out in Olean, New York. For them, they have single piece flow vulnerabilities. So it means that if there's a breakdown in part of the process, it stops the entire factory. So think for a second if you've ever seen a video of a car manufacturing. If you have a robot that's supposed to install a piece of fascia to your part, and that robot jams up, well, the entire assembly line is now stuck because you can't install that component. It doesn't mean the engine systems are down, or that the electrical systems are down, or the tires, or the frame, or the body. It's just one silly robot with a fastener that's not quite working. Same problem. This leads to them having issues in keeping their production lines running. And they were using Delrin in order to fixture the toolings and things along those lines, but it's expensive. Anybody ever machined Delrin before? I have. Is it pleasant? Not really. It's a mess. It makes an absolute mess. And it leads to a lot of long lead times. So they needed a way that they could support all their locations in these components, prevent downtimes and failures. And so they started looking into manufacturing aids and then their safety componentry. Some of the things are custom housings. If you started to talk to some of the factories out there, there's cameras now being installed, and we've got all sorts of new AI tool sets. Being able to house those, because guess what? There's a lot of workers who don't really like those, and they like to throw wrenches at things. I'm sorry, that's the reality of it. So being able to build stuff that could actually control and protect these sensors, grippers, V-blocks, housings, these are your standard kind of fixturing and tooling that slows down production. But if you normally 3D print those, and there's a bunch of people here I'm sure who have FDM 3D printed or filament printed some working fixtures, that's great, but their lifespans are fairly short. And if you want to be refreshing all that tooling every 6 weeks, well, that can add up. So having stuff that's going to be a lot longer lifespan leads to more cost savings. Now what they ended up doing is they did a hub and spoke model. So they have an additive manufacturing center of excellence. They have one building where they've got a huge amount of printing, and they're now bringing in digital models. So what they're asking is all of their locations to create digital models of the parts that they want to recreate. They either have to create it themselves, some cases they're 3D scanning those, some cases they're actually getting those files from their OEMs, and they're sending those and creating a library. So they have a digital library software called Tulip, if anybody's looking for it, that they actually are storing these files in, that they can then pull those files out and do replacements as needed ad hoc. It gives them the capability that they're able to do one-click printing. So one of the advantages that's inside the Formlabs system is that we have the whole ecosystem. So we supply the software, we supply the hardware, we supply the materials, and because of that, we have literally a button in our software that's called one click. Drop any file in, hit one click, and it'll send it immediately to the printer. You don't have to think about it. I have a 10-year-old at home. Trust me, he uses my printer far too often because he can click one click, and all of a sudden I've got lots of figurines coming out of the machines. It also means that you're not locked in to having somebody else do the work for you. You're not waiting on parts that are sitting at a dock, that are sitting on a boat. They can be produced as needed, reducing inventories and keeping material costs and maintenance cage costs lower, and keeping maintenance cage sizes smaller. I've been in some huge ones of those. So across the board, small companies and large companies have leveraged additive manufacturing to try to make it faster to get a part that's finished and usable with a longer lifespan. It's making them more agile. If you're a giant company, it's making them more efficient. It doesn't matter how large you are. There's advantages in both cases. If you're a local shop, there's places that can be helped by having additive added into it. If you're a large company, there's whole networks and additive manufacturing centers of excellence that we can help you assemble. But at the end of the day, this gives us the capability to not just buy American, but to build American. And that's really where we want to try to get to. Now, I've got a couple, one more thing. If anybody knows me, there's a couple people in the room do. I like to really put some stuff to the test. One of the things that my dad told me is any salesperson can say anything they want. It takes somebody who actually knows what they're talking about to put their money where their mouth is. So let's ask Cool Machines how they did with their testing. We will figure that. I'll do something different on that one. Apparently that one's not showing up. But we are making parts that are industrially tough. And here's what I want to get to. I am not this tall. In fact, I'm actually this tall. This entire presentation, I have been standing on this guy. So that is Cool Machines' part. That is 600 PSI survivable, frozen and then dropped off a 10-foot. That's what that staircase scene would have been. I would invite anybody to grab that part and either throw it at the ground or step onto it. Put that one through its paces. That is 3D printed. That's 3D printed in 90 minutes using our Tough 1000 material, which is equivalent to HDPE. This is a material called durable, which is equivalent to a Delrin. So is this guy. I'm going to turn the mic off for a second. So when I say that we can now do 3D printed components that are not prototypes, but are end usable parts, I'm serious about it. Here's the last one I want to show you. So this is also HDPE. It's the same thing that large piece is made of. But one of the things people know about HDPE is that it's got a lot of survivability to return to its original shape. And so this is from McMaster Carr. So I can bend this into a loop, return it back. It wants to return to its original shape. It doesn't show any wear lines or stress lines or anything along those lines. That's the real benefit of it. Here's that same material. Return to its original shape, no stress lines, no fractures to it. Put it to the test. Your old thinking of how a 3D printed part works is antiquated. The last 3 years, we have seen massive technological shifts. And if we want to stay competitive in an international market space, we need a way to make parts that are end-use parts faster, cheaper, more locally, easier to access with a shorter lead time. Thanks a bunch. I'll open it up for questions if anybody has any. But other than that, enjoy CES. Have a great day. I hope you learn a whole lot.